Hey everyone, Mr. Voikin here. We're going to be looking at Lesson 4, Domain and Range. This is Unit 7, a little bit of review. So we want to take a look at the X-Intercept and understand what that is. So first of all, if we've got a Cartesian coordinate system set up, we have an X-axis and we have a Y-axis. And if we have a line that happens to be going through those axes, where it crosses the x-axis, that is called the x-intercept, and where it crosses the y-axis, that is called the y-intercept. Now, what do we know about the x-intercept? Well, we know that the y value is equal to 0. So, for example, this point right here could be something like -3 in the x and 0 in the y. And what do we know about the y-intercept? Well, we know that the value of x equals 0. So this would have a set of ordered pairs that are 0 and +3 in this case. Remember that as we go this direction in the x, that's going to be negative. When we go that direction in the x, that's going to be positive. When I go up in the y, that's going to be positive. And when I go down in the y, it's going to be negative. So domain and range, they're just another way of saying basically x and y. So it says right here that the domain is the input. So the domain is the input. We also call that the independent variable, and it's all the values of x. And the range, it is the output. We also call that the dependent variable, and it's all the values of y. So let's jump down here to class example 1. It says list the domain and the range of the following sets of ordered pairs. Remember that x is the domain and y is the range. And remember, in a set of ordered pairs, we sort of have this set up like this. The x comes first, followed by the y. So what we're going to do is we're going to write that the domain is going to be equal to, and we do a little squiggly bracket like that, and it's all of these first values that show up here. So it'd be like the 1, the 0, the 3, the 5, and the -3. Now we could put it down in that order: 1, 0, 3, 5, and -3, followed by a closing curly brace right there. But it's best to put them in the order from least to greatest. So we're going to go through here and see what we got. So the smallest one is -3. It's going to go first, followed by 0, and then 1, and then 3, and finally 5 right there. And the range is going to be these specific values that are right here, which are going to be 2, 5, 8, 9, and again 2. So there can be 2 y's, but there can only be one value of each x. So x cannot repeat, but the y can repeat. So again, I want to put that in order from least to greatest. So the smallest one is going to be 2, and I've got 2 of those, followed by a 5, an 8, and a 9. Okay, so that is our domain and range. So if I follow that same system for this one, there's my x values, and here are my y values. And when you're doing a test using colors like this, I've said this to you many times, it really helps things stand out and minimizes any mistakes. Okay, so for the domain, it's going to equal the set of values that are here, starting with -8, -3, 0, 2, and 3. Okay, and for the range, it's going to be all the values that are going to be here, starting with, looks like I've only got 3 and 9. So it's 3, 3, 3, 3. So there's a 3 and a 9. You don't write down 3 4 times. Okay, and now let's go to the second example. So instead of looking at a set of ordered pairs, we're looking at an actual graph, but we need to do the same thing. It's asking us to state the domain and state the range of this relation. So let's look at the first one. We've got domain, and that's going to equal. Now, because we've got all these individual points, I just want to look at where it's going to be intersecting with the x-axis, and that's right here, and then it goes down right there, and here, and here. So we bring those values down until it hits the x-axis. So essentially what I've got is a -4, a -3, -2, -1, 0, 1, 2, 3, and 4 right there. And the range, well, what we want to do is do the opposite right there. I want to take these values and I want to basically run them over till they hit the y-axis right there. So for the range, I have 0, 1, 2, 3, and 4. And you might be wondering, well, what about the values on the other side? Well, if I look right here, that's hitting 0, 1, 2, and 3 right there. So they're just going to be repeating. Okay, so just minimize this a little bit. Good, let's take a look at the second one. Now, what you want to notice in this case is that we've got these 2 dots right here that are filled in. And what the filled in dot means, it's like it's at that value and includes that value. Okay, now the other one we can have is like an open circle, which means it's from that value and either greater or less, but does not include that actual value. But in this case, they're closed in circles, and we want to know, well, what is our domain? Okay, now in this case, well, if I follow the lines down, it looks like it's going to be the same as the other one. But remember that this thing has values all in between here. So there's basically infinite values. So it starts at -5 and has infinite x values all the way to and include, or sorry, it starts at -4 and includes all the values all the way to +4. And it's going to include all the number types. So the whole numbers, the real numbers, the integers, the rational numbers, and the irrational numbers. And when we're including all of them, we call that the real numbers. So these are the real numbers. So when we have a continuous line like this, that would be hitting every value within along that line, and it'd be all real numbers within that set of numbers. So I'm going to set this up a little bit different. So I'm going to say the domain equals x such that x is what? X is going to be greater than, now I'm going to have to move this one over a little bit. X is going to be greater than -4 and includes -4. So I put the little line below it. And it's going to be less than +4 and including 4. And I put a comma right here, and that reads such that x is a subset of all real numbers. Okay, so this reads x is such that x is greater than or equal to -4, and x is less than or equal to, why did I put the equal sign underneath the 4? Move up there to +4, and x is a subset of all real numbers. This means x is a subset of all real numbers. So the domain equals x such that the x is greater than or less than -4, and it is less than or equal to +4, and x is a subset of all real numbers. So sort of a weird way to write it. Now let's take a look at the range. Okay, well, if we look at the lowest value, it's going to be right here at the 0. And the highest value is up here at +4, and it's going to be everything in between, because I can basically go across and hit that line at infinite positions. Okay, so I'm going to set this up the same, where I'm going to say the range is all values of y such that y is what? It's greater than or equal to 0, and it's less than or equal to 4. And y is a subset of all real numbers. So you just got to get used to laying it out in that fashion. Okay, now we're moving on to the last case right here, where I have a closed arrowhead, which basically tells me that this would go on forever and ever in that direction. Now, what is it doing? Well, it's going down, which is negative in the y value, and it's also going to the right, which is positive in the x. So it's going to keep going this direction infinitely, and it's going to keep going down infinitely. And on the other side, it's also going down infinitely because of these arrowheads, and it's also going to the left infinitely. So essentially, because it's going left infinitely and right infinitely, the values of x are going to be literally everything. Okay, so the domain is going to be domain equals x such that x is a subset of all real numbers. So it basically goes forever to the left and forever to the right, including all values of x that are real numbers, which is every number. And what about in the y? Well, it's starting here at 4, and it's going down again infinitely. So the range is going to equal y such that y is going to be what? Y is going to be less than or equal to 4, and y is a subset of all real numbers. Okay, so there we go. That's those 3 examples right there. Now let's move to the next example, number 3. Now we're looking at some other graphs, and it says state the domain and the range of these relations. Okay, let's look at example A. And we got this arrow that's pointing up and to the right and up and to the left. So again, it's going to go infinitely right, infinitely left, infinitely up on both of these. But it doesn't go infinitely down. That's sort of the vertex, the lowest point right there. So this would be our minimum point right here, which looks like it lines up with -1, 2, 3. So that's at -3. So if I talk about the domain here, it's going to equal x such that x is a subset of all real numbers. And the range is going to equal y such that y is greater than or equal to -3, and y is a subset of all real numbers. So it starts at -3, includes -3, and goes forever in the positive direction, including all real numbers. Let's take a look at b. Now, if we look at b, we're saying, well, it's sort of got a limit on how far to the left it's going on the x and how far it's going on the y. So I can see it's sort of stopping here at -2 and going up to 4. And in the y direction, it's sort of got a limit right there, which is going to be 1, and a limit right there, which is going to be -3. So, and because this circle, is sort of all the way around like this, if I was to take any point on that line, I can go and sort of touch the x-axis, and if I do the same thing the other way, I can go over and touch the y-axis. Okay, so it's going to be all the values in between and including those points that I marked out. So the domain is going to equal x such that x is, now I'm going to move this over because I've got a greater and equal to. So x is going to be greater than and equal to -2, and it's going to be less than or equal to 4, and x is a subset of all real numbers in between that range from and including -2 and +4. And the range is going to equal the y value such that y, and I forgot my such that x, such that y is, oh no, I didn't forget that, sorry. I just want to move the y over, such that y is, well, again, I want to say it's greater than or equal to -3, and it's less than or equal to 1, and y is a subset of all real numbers. Okay, and we're going to look at this sort of arrow map that's right here. Remember, these are my x values going up and down right here, and my y values are right here, which are in that column right here. So I just want to go back and set this up again. So the domain is going to equal, in this case, it's just those points. So it's going to be 1, 2, and 3, and the range is going to equal 2 and 6. Okay, and moving on to the last one. Now we have a sort of a word problem right here. It tells us we got a circle, and it's got a center at -2 and 3 and a radius of 3. So we know that radius is half the circle. So we could draw this out or just use some math. So if I know the center is at -1, -2, so I'm just going to draw some little increments right here. So it's at -2 in the x and +3 in the y. So that is our center of the circle. And if it's got a radius of 3, that means it's going to be going to the right. 1, 2, 3. It's going to get to that point. It's going to go to the left. 1, 2, 3. Need one more little hash mark right there. Extend that one out. And it's going to go up. From here, 1, 2, 3, so I would have to extend this one just a little bit, and it's going to go down 1, 2, 3. So essentially what we've got is a circle-ish, close enough, a circle that's going between those points right there. The reason they don't touch all the points is because my increments are not exactly there. The precision is lacking. Okay, but what values are we going to and from? Well, let's deal with the x. It's going from this point right here, which happens to be -1, 2, 3, 4, 5, 6. and it's going to that point right there, which was 1. And the y was going from there, which is positive 3, down to this point, which is 0. So the domain is going to equal, and be just like this circle one right up here, where it was all the values in between. So the domain is going to equal x such that x is greater than -6, equal to -6, and it's less than and equal to 1. And I may have to just shrink this down a little bit so I can fit it in there. X is a subset of all real numbers. And what about y? Well, that's the range, and y is such that y is going to be greater than or equal to 0 and less than or equal to 3, and y is a subset of all real numbers. Okay, there we go. And when you're laying these out, again, it's just going to be repetition to get this formatting down. And it works good if you say it to yourself so that you sort of ensure that you have those terms and the format down properly. So it says draw, class example number 4, draw the graph of a relation where the x is a subset of all real numbers and the range is such that y is less than or equal to 2 and y is a subset of all real numbers. So it says on this one, let's make it with 1 x-intercept, and this one says 2 x-intercept. So the first thing I would do is draw a Cartesian coordinate system right here, and I want 1 x coordinate, and it says that y is less than or equal to 2. So that means y is equal to 2, the y-intercept right here. So that'll be 1, 2, 3, 4, 5, it'd be at 2. And, and it's greater than, no, y is less than or equal to 2. So it's from this point going down. So essentially what I need to do is draw a line from here coming down either in this direction. You can see that goes through the x-axis at only one point, or it can even go in this direction as long as it's crossing the x-axis in only one point. So I'll go like that. And now because it says that the x value is a subset of all real numbers, that means it's going to go forever and ever, which means I need an arrowhead pointing down and to the left. Okay, and that should make that one true. Now this one says let's draw one with 2 x-intercepts, and that means that cannot be a straight line. And what we're usually going to be looking at is a parabola, which is going to be either drawn up like that or down like that. Okay, so and what does it say? It goes to point number 2. So again, it goes 1, 2, 3, 4, 5. It goes to that point, and it's going to be going down. So it's basically going to go up to that point and down right there. I might have to move this up. It sort of reshaped itself. Okay, and I'm going to have 2 arrows like that and like that. So you can see right here I have 1 x-intercept, and right here I now have 2 x-intercepts, and my graph follows the domain and range that is set up in the equation. Okay, so it says explain why it is not possible to draw a graph which has a domain of all real numbers, and y is such that y is greater than or equal to 2. Okay, so y is Explain why it is not possible to draw a graph which has domain and no x-intercepts. Okay, well, it's basically because of this right here. It says it's a subset of all real numbers, which means it's going to continue to go down forever and ever. So if I look here, it looks like this one and this one are exactly the same. So y is such that y is less than or equal to 2. Okay, so basically if we're drawing this thing out, remember that it's starting here at 2 and it's going to curve down. Now, we could have one that doesn't go infinitely like this one does. So it could just be going like this and sort of stopping at those 2 points right there. But in this case, because it says that it's a subset of all real numbers, that means that it's going to go down. And if it's going down and starting above the x, it has to go through the x-axis at these 2 points. Okay, let's take a look at this example, and it's very standard type question. We have this caterer needs to set up a banquet, and the caterer tells this football team that it's a minimum of $500 to hire him, and basically that is the setup cost for the caterer. So $500 just to get him to accept the job. At that point, he or she tells you that for every person that is invited to the event, they're going to pay $20 for the food. And if we notice here in part A, it says we got a minimum of 100 people and a maximum of 500 people. So if you only have 50 people, the caterer is not going to take the job. It's just not enough, not worth the person's while. They're not going to make enough money. Basic business. And if there's 600 people, the caterer says that's just too many. I don't have enough staff or facilities to be able to take care of that many people. So in this case, it makes quite common sense that if I've got 10 people coming, that is times 20 per person, that's $200, plus the 500 initial costs, that's going to be $700. So it tells us to fill out the table of values and start here at 100 and go up by a certain amount. So we'll go 200, 250, 300, 350, 400, and well, we got to get to 500, so we'll make that 500 right there. And we've got this equation that they've written that says the cost, uppercase C, is equal to 500, which is our initial charge, plus you're going to pay $20 for every other person. So N right here is the number of people, and C is the cost of the banquet. And remember that the first column is going to be X and the second column is going to be Y. The X is our input, which is going to go into that point right there. And the output is going to be our Y, which is that point right there. So basically what we want to do is say the cost is going to equal to our 500 plus 20 times whatever I put inside those brackets. Now, if I put in 100, I'm going to have 500 plus 20 times 100, which is 200. Nope, it's 2,000. So I've got a total of 2,500. Now, what we want to recognize is that I set this up with standard sort of jumps. So between 100 and 150, it went up 50, plus 50, plus 50, plus 50. But notice down here, we've got to change its plus 100. So that means from here to here should be the same, and here to here should be the same, and here to here should be the same. And down here, because this is double that, then this one right here will be double whatever happens to be right there. So we don't know the intervals on the output yet, but let's do the second one with 150. So I'll just erase that and that. We'll replace that number with 150. 150 times 20 is 3,000. And 3,000 plus 500 is going to be 3,500. Which means we had an interval of 1,000 on the output, plus 1,000. So in theory, this next one should be 4,500. But let's just make sure our thought process is correct. So we'll replace this with our new n value of 200 people. 20 times 200 is 4,000, plus 500 is 4,500. That's correct. So it would now go to 5,500, 6,500, 7,500, 8,500, and the last one would go up by 2,000 because it's going to be double what the other one was. So this will be 10,500. Come on, pencil. Good. Okay, so there's our table of values all filled out. Now it says plot the 8 ordered pairs on the grid. So besides doing that, I'm going to just set this up properly. So right here, this is going to be our x axis, and right here, this is going to be our y axis. So this is going to be y, and this one is going to be x. X is our input, which in this case is actually n, and y is the output, which in this case is actually uppercase C. Okay, we want to label this, so this is going to be our cost. And down here on the x-axis, it's going to be the number of people. Okay, remember this is going to be our independent variable, and this one is going to be our dependent variable. Okay, now if we look at all these lines in the graph, these darker ones are the major lines. There's 1, 2, 3, 4, 5, 6, and along the x-axis there's 1, 2, 3, 4, 5. We're going to be starting off at 0 and 0, and we need to get at least to 10,000 on the y and to 500 on the x. So 500 divided by our 5 major lines makes it sort of easy to fill this in at 100, 200, 300, 400, and 500. Okay, now if I just randomly chose to do like 3,000, or I'll start off with a smaller number, like say 1,000, 2,000, 3,000, 4,000, 5,000. I can't all of a sudden go, ooh, I need to get to 10,500 and go 10,500. These have to be consistently the same value for the same number of steps. Okay, at the same time, I don't want to just choose a very large number such as 5,000, 10,000, 15,000, 20,000, because now basically this whole part of the graph isn't being used. Everything's going to be down in this area down here. Okay, so we want to choose numbers that's going to utilize most of the graph. So after sort of figuring things out, I think by going 2,000, 4,000, 6,000, 8,000, 10,000, and 11,000, well, that's not what we wanted now, is it? Okay, that's going to get us to up and above and over where we need to be, which is fine. So we're not going to end up using anything up in this space, but it's good to have that buffer zone. And actually, if I was to redraw this myself, I'd probably make this to have 6 sort of major lines so that I have a little buffer zone over here as well. Okay, this graph should also have a title. So cost of banquet. What is going on with my, there we go, banquet. Okay, and let's take a look at that first ordered pair. So it says at 100 on the n, go up 2,500. So 100 on the end, go up 20, 400, 2,500. And on, let's go to the last one, which is on the 500, go to 10,500 right there. And essentially, this should form a straight line between those points. Okay? Now, if I was to follow this line down, you can see that it ends up right here. And that value right there happens to be at this position 0 and 500, which is how much the caterer was starting out right at the beginning. But remember that we're not going to be including any data between that 500 and the first 100 people. Okay, so our graph is going to start right here and it's going to end right there. So it's going to have sort of an X values between here, and it's going to have Y values between here and there. Okay, now it tells us to plot all the other points, and they should just fall directly on this line. Okay. Okay, part C says show the domain and range. Well, I've already indicated those. The domain is going to be from here to there, including those points, and the range is going to go from here to here. And now I just want to think, well, what do I want to include? Do I want to have all like whole numbers or natural numbers or integers or real numbers? Well, it's not going to be real numbers because we can't have fractions of people. It's not going to be integers because we're not going to have negative people. So essentially, we're going to be looking at like the natural or whole numbers here. Okay, so let's start off with our range. Our domain. So the domain is going to equal x such that x is greater than or equal to 100 and less than or equal to 500, and x is a subset of all natural numbers. And the domain or range is going to be y such that y is greater than or equal to 2,500 and less than or equal to 10,500. And running out of space here, so I'll just make that a little bit smaller. Okay, and y is a subset of, now we want to think about the dollar values, so it looks like we're going to be going by 20, so it's going to be subset of all natural numbers. Let me think about this. Okay, yeah, actually I don't like this, because when you think about it, really it can't be all the natural numbers, because we're jumping up by each person. That's going to be one person, two people, 3, 4, 5, 6, 7. So we're going to hit all the natural numbers in sequential order there. But the y values are actually going up by 20 each time. So I can't say it's the subset of all real numbers, because a number like 2,521 is not going to be possible. So I'm going to have to rewrite this one. Think about it for a second. So the range is going to be okay, it's going to have to be like, what are we starting out at? 2,500 going to 2,520 to 2,540. And now we don't have space or the time really, or it would just be really messy to write out every single one. So we can just write like dot, dot, dot. Which basically means, so there's going to be values there. Let me move this down a little bit so we have some more space. And then we'll put in sort of 3 on the other side. Sounds pretty good. So we're going to be going to a maximum of 10,500. So we're going to have 10,460, 10,480, and 10,000. That's not a 10,000. 10,500. And close it off like that, and that should be good. Okay, and there we go. We're at the end. So there's a lot of work you can see that goes into this. You just really got to think about each one of these sort of situations to make sure that you're not making small little errors in things like the way you lay out the domain and range, like I almost did. Is it including things? Could it be natural numbers, integers? Is it sequential, one by one, or are they skipping numbers, etc.? Okay, after that, we're on page 426 of our assignment, and all the way through to page number... It keeps going and going. There we go, 431, and the answers are on page 432.